Okay, so taking a look at basic CUCM call routing logic to begin with. We see we have a few different patterns here. Okay, so these look like they are external PSTN patterns of some type. And to begin with, we see that we have 9 dot, left bracket 2 through 9, or 2-9, right bracket, and then we have 6 X's. So as we begin looking, the dot, or the period, is a delimiter. It does not match any digits, so it doesn't really take up a digit place. It's really just used for discarding anything before, and discarding itself, even though since it's not a digit or match one, it doesn't really need to. It's just a delimiter. But it's used for discarding anything before itself. Wherever we place it is entirely up to us. And we'll look at, over the course of the next few days and next few modules, look at where we might want to place that. And that's going to change as we go through modules, as the concepts evolve. Next, we see a left bracket 2-9 right bracket. Anything within a left-right square bracket matches exactly one digit. Okay, so if we have 2-9 in that left-right bracket, we're matching any one digit that is the numbers 2, 3, 4, 5, 6, 7, 8, or 9, the DTMF digits. We're not matching 0 or 1. If we wanted to match 0, but not 1, and 2 through 9, we could modify this and say left bracket 0, 2, -9, right bracket. So there's no need for a comma separating them. But if we just have 0 and then directly next to it 2, this is the number 0 or, this is Boolean or the number 2, the DTMF digit 2, and then the range of 2 through 9, but not 1. So we can put numbers next to each other in these left-right brackets. But again, this only matches exactly one digit as a sort of a wild card. Then the rest of the capital X's match any single digit between 0 and 9. It's important to note that they do not match star or hash. Hash, sometimes called pound in the US, sometimes called octathorpe, is actually the proper name for the hash. Okay, but it's important to note that these do not match star or hash. Star and hash are valid DTMF dialable digits. Technically, A, B, C, and D are valid DTMF tones as well. It's just that not many, keypads actually have them on them. So typically only systems can dial with the A, B, C, and D DTMF tones, unless you happen to be a nerd like me and you actually have a DTMF tone generator. Anyway, moving on. We see in the next pattern 9 dot. We've already covered the dot as the delimiter to discard pre-dot. We see 9.0 and 1. Some people refer to this as exclamation. You'll hear me often, just because exclamation is a lot to say, you'll hear me refer to it as a bang, okay, or a ball bat. Some people refer to it as a ball bat or a bang or a exclamation. This matches one or more occurrences of the digit between 0 and 9. So this gets into similar to a regular expression, but a regular expression of a plus, but not exactly. A plus in regular expression matches one or more of the preceding digit. This just matches one or more occurrence of any digit between 0 and 9. And of course, plus in regular expression is a lot more inclusive than just digits. It's alphanumeric. But not trying to confuse you too much, but this bang, again, does not match an asterisk or a hash, but note that it does not match nothing. Okay, so someone could not dial 9011 hash and it match. That bang or exclamation has to match at least at a minimum of one digit before it's satisfied. But it can also match infinite number of digits, anything beyond or including 1. And next, the hash symbol is typically used to avoid interdigit timeout, but it can also be a dialable digit. We're noting, actually one person was noting that I was cutting in and out pretty badly. Is that still the case? Can everyone hear me fairly well, or actually cutting in and out? Okay, a little bit. Okay, if you would, let me know if that continues to happen. It could be the high CPU. Well, it's not really high, but I have about 50% CPU just running a few different things for our tasks later. Let me know if that continues, and I will certainly pause and fix that issue if it's on my side. Okay, so the hash can be a dialable digit. When it comes at the end of a dialable string of a pattern, it's typically used as a interdigit timeout symbol. Okay, so really all it's doing is matching a dialable digit. Someone presses hash on their keypad. They want the call to go through immediately. They're just an end user. They don't even know necessarily what the term interdigit timeout is, but they just want the call to go through immediately, typically an international call where there are variable length addressing schemes. But what they're doing is actually dialing a DTMF hash, and we're matching the DTMF hash. Okay? So the only way that it's avoiding interdigit timeout is that we have now completed or put an end to the possibility of matching multiple occurrences of that last ballbat or exclamation. Okay, so since the exclamation, if we go back a step, was one or more occurrences, the or more we said could be infinite. So once we dial the hash, user presses the hash, then we have essentially said there are no more possible digits that can be dialed because the ballbat, the exclamation, does not match star or hash. If it did match hash, then it would just be another possible digit that it matched, and it could go on infinitely. Since it cannot match a hash, and we dial a hash, and there's a hash in the pattern, of course we have to set one up with that for it to match, that's when we have essentially said we're done matching any other potential random wildcard digits, 0 through 9, and we now have a complete match of a pattern, and we're certainly going to look in just a moment at specific patterns. Okay, so now we know that we've got the complete pattern. Now we can go ahead and route the call to wherever the route pattern points, all of what we'll look at in just a moment, but we still have to do something with that hash. We have to get rid of it. So we'll talk about discard mechanisms. Some we just talked about, like pre-dot. We'll also talk about pre-dot and trailing pound and what the defaults are. The cutting out might have been actually just me pressing the talk key to stop talking so that I could breath. I've had just a little bit of coughing in between the talks, so I'll try not to do that as much. Okay, and then the next we have a 9 dot, and we've got this @ symbol. Okay, now that's obviously not a dialable DTMF digit. We're not talking about email addresses here. This is a macro that basically calls a numbering plan, the North American numbering plan being the default with CUCM, but certainly by no means the only standardized numbering plan that can be uploaded and integrated into CUCM. Calls this numbering plan into consideration. And it's been mentioned that it was not yet utilized in the CCI voice exam. Now, in years past, actually before really almost 1 year ago, in about a couple weeks, July 19th, I think, of 2009 was when the lab switched to version 3 of the CCI voice blueprint. And prior to that, the CCI voice blueprint for 2.0 actually said, when it talked about route patterns, @ symbol is not tested. Okay, it was said to be an international an international exam. Okay, so not only U.S. or North American numbering plan numbers would be there. There would definitely be international site or sites, and that's certainly continued. But with 7.0, which is what the lab switched to, CUCM version 7.0, back about a year ago in July of 2009, we brought into consideration with 7.0 a true globalized perspective on dialing. Everything that we're going to set you up to fully understand the premises and fundamentals of today, and then go into that fully exploit it tomorrow in the next couple lessons. So in the current blueprint, it doesn't actually any longer say that the @ symbol or numbering plans in general are no longer tested. It doesn't say that anymore. So they are fair game. It has been noted that they have not been tested yet. Okay, so this is about a year after the Voice 3.0 blueprint went into effect, but that they very well could be in the near future. So it's important to understand the @ symbol and what it can effectively do. It can call into play a numbering plan. That numbering plan has to already be uploaded and implemented in the CUCM call manager configuration. In terms of, well, it has to be uploaded. In terms of being implemented, that's your job when you actually configure a pattern and call into play that @ symbol, that macro in the actual pattern field. You also, in the route pattern, have to specify a numbering plan. And then you can also specify numbering filters. Okay, so you select from a drop-down of the available numbering plans. So let's take a look at CUCM pattern options. We see that to begin with, we've got 0 through 9 and then *#. Those match exactly one keypad button, or one DTMF keypad button. X, we said, was any single digit except for star or hash, so 0 through 9. If we see something like left bracket 1 to *5, right bracket, it's exactly any one of the keypad buttons in the bracket. So what buttons are these? What does 1 to *5 match? What are the possibilities? And present the first question. The reason I'm asking is this could be a little tricky. That's exactly right. Christopher said 1 to *#. It could be perceived, and as I've just kind of ad nauseum maybe gone over the fact that star is a DTMF digit, it probably shouldn't be, but it could be perceived that this is some sort of a wild card, like 1 to anything 5. Why even put that there? It could be anything there. No, that is an actual DTMF digit. So it could be any one of those 4 DTMF digits, but it's only exactly one of those keypad items. And then 4-9 is exactly any one of the digits between, so 4 and 9 included, and then also 5, 6, 7, 8. Then we have one that most people don't typically think of, and if you've done any sort of work in iOS, whether on SIP or H323 gateways, you've probably seen the caret symbol as a regular expression that denotes the beginning of a string. And we'll be talking more about that tomorrow when we talk about voice translation rules. And that's true in iOS. It's true. Although regular expressions to some degree can be used in CUCM, this is not one of the ones that is really being considered a regular expression. This is a special CUCM specific wildcard, or not wildcard, but operator. And this is saying exactly any one digits in the brackets that is not between 3 and 7 inclusively. So it could be 0, 1, 2, 8, or 9, or star or hash. Okay? So one or more of the digits in the range of 0 through 9 is the ball bat, the bang, we just talked about that. The question mark and the plus, those are 2 regular expressions. The question mark does the same things it does in iOS. This is a regular expression that indicates 0 or more actually I believe it's 0 or 1, of the previous wildcard or digit. So if I had, let's say, a pattern that said 1 question mark, then this could match 1 nothing, because it could match 0 or more. It could match 1 1, and then that's it. Plus is a regular expression that indicates 1 or more of the previous wildcard. So if I had a, let's say, a DTMF digit 8 plus, that was the pattern, 8 plus, that would match 8 8, but it would not match 8, okay, because the plus says 1 or more, not 0 or more. It would match 8 8. It would match 8 8 8, 8 8 8 8, 8 8 8 8 8 8 8. Okay, so it would continue, but it has to be the previous digit or character. Now, if I combine that with a wildcard, let's say X and then plus, well, then all of a sudden I have a wildcard that matches 0 through 9, but not star or hash. So it would match, you know, would match 1 3, 4 5, 4 5 6 7, 4 5 9, 7 3 8. Okay, so I think you get the idea. You can play around with regular expressions if you find a need to use those. Note, though, that the plus is a regular expression, and so tomorrow when we talk about, in the next module, when we talk about globalization and we talk about plus dialing, if we want to use it as a literal string, as actually part of the calling or call-led number, then we have to escape it. If we simply put a plus in a pattern field, then it is considered a regular expression. If we put a escape, which is a backslash, and then the plus, then, as in most programming languages, it's considered a literal string. We've escaped its operative or operator properties. We already said the @ is the numbering plan macro, and then nothing is also a valid pattern. It immediately routes the call because it basically matches once absolutely 0 DTMF digits have been entered, which is the same as going off hook. We'll look at that today with our very last task for PLAR, private line automatic ring down. Okay, so let's take a look at some pattern matching exercises. So here we see 1 1 1 1 matches 1 1 1 1, star 1 matches star 1, 12XX, so 1 2 XX. How many numbers does this match? Someone want to give me a guess? And I'll enable everyone's mics so you can talk back if you'd like. Make sure you maybe raise a hand real quick so that I can mute mine so we don't get any feedback. That's correct. Everyone, very impressed. Everyone said 100. It does not match 99 because counting canonically, 0 is also a number. So 1200 is the first number, and then we have 1 through 99. So it matches 100 numbers. That's exactly right. 1325-8, 6, 25-8 in the left-right brackets. That matches everything we see here to the right. 1326, 1356, 1366, 76, and 86. Okay, but it does not match 0 or 1, 3 or 4, or 9. Okay, we also see 13 caret in the left bracket, 3-9. So this is going to match 1306, 1316, 26, 13*6, and 13#6. And then we see 13 bang hash. So this matches exactly 13 one digit or infinite number of digits, provided that the user does press the hash. They have to press it for it to match. Otherwise, if we wanted it to match just with infinite digits 0 through 9, we would only enter 13 bang or 13 exclamation. So looking at the @ symbol and route filter logic, we're not going to go too much into route filters and numbering plans, but we do need to have at least a basic understanding, and if desired, we can certainly look more at those at a later time, but we'll definitely look at the basics and understanding them. So if we have a route pattern such as 9.at, and this is much more specific to the North American numbering plan. Okay, if we look at most of the EU, they dial typically with 0 as a PSTN access code. Actually, save the UK. The UK typically uses 9 as well as a PBX PSTN access code. But 9 being our PBX PSTN access code, 9 dot is so that we can have a delimiter to strip pre-dot, and then the @ symbol calls into effect all of the North American numbering plan. The North American numbering plan is represented by a very specific plan. You can look it up. In 4.x, you could actually look at it on the CUCM as a downloadable text file, or look in the file system. It's probably still in the file system. You just have to know where to look for it. But there is a, find it on Google or Bing it. It's very easy to find the North American numbering plan. It represents a very robust and somewhat complex set of rules, these being just the basics. Okay, there are a lot of rules in there dealing with things like what we call PIC codes, 1010 codes, and various things like that to avoid toll and various toll-free or toll numbers. But anyway, when we call all of that into play, then we need to begin saying, let's look at the individual specifics, such as over to the right we see 9 dot, left bracket 2 through 9, right bracket 1, 1. So most people in the US and maybe even outside know that 911 is emergency. Okay, in the UK it's typically 999, although that's changing to match what most of the EU is, which is 112. Okay, but we also in the US or North America, can't forget Canada certainly. Mexico used to be part of the North American numbering plan, but they are not any longer. So although much of the dialing does still remain fairly similar. So anyway, 2, 3, 4, 5, 6, 7, and 8, 1, 1 are various types of services. For instance, 411 is a common information service. Some of these are toll, some of these are not. Okay, so these are various services that are provided by various locales. Not every locale provides it, but some do. Then we've got a older format of local numbering or local dialing, which is 7 digits, and the first digit can only be 2 through 9. It cannot be 0 or 1, certainly not star or hash. Normal numbering in bigger cities, or actually even in many cities in the US now, is 10 digits. Okay, so we include the geographic or area code. 9.1, 1 symbolizes a long-distance access code. Okay, long-distance or national or geographic access code. It says that what follows next is 10 digits, and the first 3 are going to be the area code or geographic code. Okay, to contrast that, much of the EU uses 0 as a long-distance access code. Now, it should be noted that the US long-distance or national access code happens to be the same as our country code. And many people that live in the US, if they haven't traveled, or even if they've traveled, they haven't dialed internationally when traveling a lot, don't necessarily realize what a convenient mechanism that is, to have your long-distance access code also your country code. And as we look at globalization more tomorrow, you'll see how convenient that is. But in many parts of South America, I believe even Australia, it's 00, and then a carrier code as your long-distance access code. And then in most of the EU, it's just 0. Then, looking at the US international, is 9.011. So 011 is the North America PSTN international access code. Okay, much of the EU is 00, and then places like Australia are 0011, and then your country code. Okay, but this indicates international dialing. So CUCM identifies tags in each number. Okay, tags represent sections of the digits, and you can see over here I've got the digits a bit parsed out. So we've got 9 dot, for instance on the local, the second number, 9 dot 2 through 9 XX space XXXX. And the 2 through 9 XX, if it's only part of a 7-digit number, the 2 through 9 XX, this actually indicates a prefix. In the US, we call them NPA NXs. NPA also equals an area code in terms of terminology. NXX also equals a prefix or a locale code. So within an area code, much of the world calls that a geographic code or geographic area code. Within that, it's broken down even further into what are called prefixes or locale codes. So different areas, different sub-areas within that larger geographic area. So typically, an area code represents a city, and there's many cities that have many area codes just because they've grown well beyond one area code. Many of the small to medium sized cities only have one area code or geographic code. Okay, so looking at the third pattern, that's that 9.1, and then the first 2 through 9, that indicates the area code. And that's where we see the CUCM identifies the tag as that area code. International access, okay, so that's the 011 as part of the fourth pattern. So these are the different tags that map to the various parts of the numbering plan. And again, if you Bing or Google the North American Numbering Plan, or just NANP, you will see how these tags are actually set up. So CCM route filters call these tags with the proper ITUT E164 naming convention. So these route filters then, we call certain things into play. So maybe we say international access does not exist and area code does not exist. So if those two are the case, then that pretty much eliminates the fourth of those patterns, 9011, because that's an international access code. An area code does not exist. That eliminates not only the long distance for 91, 2 through 9 XX, where there's still 7 digits, 2 through 9 XX, XXXX. It eliminates that one, but it also eliminates local numbers that have an area code. So if I wanted to include, and this is going to be local only, so I'm going to, at the end, just get 9, 2 through 911, because that would be considered local, and 9, 2 through 9 XX, XXXX for a total of 7 digits plus the PSTN 9 access code there. Okay, but note that it would not include a local number that I described but is not on the screen, such as 9 dot 2 through 9 XX, 2 through 9 XX, XXXX. That's a local number because after the 9 dot there was not a 1 long distance or national access code. But it would eliminate, this route filter would eliminate that from being a possible dialable number matching that pattern. Okay, we could include that by just changing this route filter to say international access does not exist, and I believe it's, have to look at the actual route filter, make sure I have the name proper because I don't use route filters and the @ symbol too much. Get into why in just a moment. But I could say international access does not exist and long distance access code does not. Area code could still exist, but just no long distance or national access code would exist. Okay, so the 9.1 and then 10 digits would not match, but 9 dot and then 10 digits would match. Okay, so route filter configuration. Here we see just the beginning of it where we see area code. These are part of the clause. We see the route filter that's already been configured up here is numbering plan is North America. We're talking about long distance calls is just what it's been named, and the clause is area code exists and international access does not exist. This is just part of the configuration. And you note down here that we don't see anything selected. That's because there's already been a clause set up, but now we can actually create, what we can do is we can create Boolean ands and ors. So we can do ands within clauses, and then we can have multiple clauses ORed together. So we could have, for instance, this clause that says area code exists, Boolean and international access does not exist. And then we'd have an or separator, and we'd formulate our next clause, and at the bottom we'd hit save and update. Okay, but one limitation, well, probably a few. One is that the entire route filter cannot contain, or it can only contain up to 1024 characters. Okay, this does not include the not selected field. So these here being the characters. Area code exists, so area dash, that dash included, the space is included, exists and is included, all of that. So we can only have a total of 1024 characters. You'll see, if you've done any sort of dial plan development with numbering plans, North America or otherwise, and route filters, that you can quickly, especially with overlapping area codes or prefixes, some places where maybe a prefix, that second set of 3 digits, or actually even an area code overlaps within 2 different cities that are part of the same cluster. Some places within one city are long distance, or you have to include a national or long distance access code such as 1 to dial it. Other places you do not. Where I live is actually a perfect example. If you're in the 614 area code or the 740 area code or geographic code, some places within the city you have to dial 1, a long distance trunk code to get there. Others, you don't dial that. So the types of route filters and and or clauses that you have to set up can be fairly complex, and you can actually quickly get into a situation as you break out these what are called NPA NXXs, or these prefixes within the area code. You can quickly get into a situation where you don't have enough characters to contain all of what you need to match the route filter. In that case, what you have to do is put in as many as you can until it gives you the error that you can no longer fit any more characters, and then you have to create a second 9.out pattern with your continuation of the route filters, and then put them in the same pattern and organize them, and we'll get into the idea of partition ordering in just a little bit. But it can get fairly messy. I'm not too concerned that they're going to put these on the exam, but they could. It, especially with international plans, could make things very interesting to say the least. But again, since that @ symbol not being tested is no longer on the blueprint, it is possible that they could test with route filters and the @ symbol calling into place one or more numbering plans. Okay, so now let's take a look at longest match routing. If we have a user that dials 1200, CUCM matches the most specific pattern, okay, the longest match logic. I've had some people ask me, is it most specific or longest match? In terms of CUCM, it considers both the same. Okay, so it is the most specific or longest match, same thing. So we've got a 1XXX route pattern that points to gateway 1, but we have 12XX that is more specific if the user dialed 1200, and that points to gateway 2, so the user would be routed to gateway 2. The user dials 1234, that's even more specific. Now that happens to be a registered directory number. First of all, directory numbers can contain wildcards. They don't have to be as specific as most people are used to provisioning them, and there might be reasons why we want to do that at some point. In terms of directory numbers, CUCM considers a directory number or a DN as a pattern, as a route pattern. Okay, in fact, in the SQL table, the Informix database SQL table, it pretty much always has been that all the patterns, whether they are translation patterns, route patterns, meet me number patterns, CTI route point directory numbers, 79, 65 directory numbers, doesn't matter. They're all in a single table called DN or pattern. Okay, so directory numbers are not considered any different. Okay, so let's take a look at an actual longest match scenario as the user's dialing it, and we're also going to, at the bottom, we're going to look at the SDI trace. Okay, so we haven't quite talked about partitions and calling search spaces, but there is something in the trace that I want to point out. So as a user goes off hook and they begin dialing, here we go, off hook, CUCM says provide dial tone, and it shows down here at the bottom, we see that the digit analysis matches the, first of all, the CN, or calling number, of 15644, and the fully qualified calling number of 919-555-5644. Okay, so what's the difference between the calling number and the fully qualified calling number? Calling number is the person's extension. The fully qualified calling number is their external phone number mask taken into consideration. So we've got a user here in RTP, 919 area code, 555 prefix, 5644. Okay, notice that 5644 matches the last four digits of the calling number, their extension, but if we go over one more digit, 5 does not match the 1. That's fine. The external phone number mask is probably 919-555-XXXX, and XXXX, 4 X's, would pull into play the last 4 digits, or the first 4 most significant digits, counting from the right to the left. And then 1 is just part of the extension number, but doesn't become considered in the external phone number mask. Okay, so first of all, we're matching who's dialing. Then we also look at the PSS. Now we're going to talk in just a moment about CSSs, which are calling search spaces, and really fully understand those. And then we're also going to take a look at partitions and how calling search spaces contain partitions. Okay? A PSS is the way the trace looks at it. This is the partitions within the search space. So this is the partition search space. So in other words, based on everything we're about to talk about with calling search spaces and partitions, whatever sort of partitions are taken into account, and we'll cover those in just a moment, in the one or multiple calling search spaces that this user has available to them, we're going to conglomerate everything together or concatenate it into something we'll call a partition search space. Okay, so PSS are the partitions within the search space. So here we see that this user has partition PA, line 1, partition Cisco, partition local, partition long distance, and partition international. Within all of those partitions can be a search space or searched for the DD, the dialed digits. And right now, the user's only gone off hook, so there are no dialed digits. So currently, the digit analysis says potential matches exist, or potential matches equals, in other words, are there any? Question. Currently, potential matches do exist. Anything in the numbering plan exists when all we've done is go off hook. Okay, so let's look a little further. Now the user dials 1. Okay, we see that the dialed digits change to 1 here, and there's still potential matches that exist. In fact, everything here is a might match, a potential match. CUCM breaks the dial tone. Okay. Then the user goes ahead and they dial 5. All of a sudden, we now have these cut out. They no longer match. But we do have a number of others that are still potential matches. Actually, my dial digits down here are not going to match what is up here. That's because I updated the slide and I forgot to update the trace. Okay, so this would say 156, not 131. But anyhow, the user dials 156. Okay, now let's see. A little bit broken on this slide. This is no longer a match, so I apologize. This is still a possible match. This is still a possible match. And this is already a match, but it's also a possible match because 1, 5, anything has been met. At least one more digit has been met as far as the criteria. However, there could be more. Okay, so then we dial 1565. Now this, 1, a single digit here, so 2 didn't match, 3 didn't match, 5 did. And then 6 and 5, that's a match. 1, this single digit of 5XX, that's a match. And then this is still a match and a potential match. So then we have CUCM timeout. Okay? And the timeout would have to occur because this would hold up these other two patterns for matching unless they had what? What would these patterns have to have configured on them in order to have taken effect and not allowed this to continue to possibly match? Anyone have a guess? They would have to have the urgent priority checkbox. Someone said a hash. If they had a hash, then the user would have had to dial a hash. But if either of these had the urgent priority checkbox checked, that says this is a match. Do not continue to wait for more matches. Okay? However, if they didn't, and in this case they didn't have urgent priority checked, then there is still another potential. It's already a match, and it's a potential match for more digits. So we have to wait for something to occur. In this case, either a star or hash, something that this exclamation doesn't match, or simply an interdigit timeout. So now CUCM says extend the call to the best match. My question to you is, which route pattern of these three that currently match, which one is the best? In this case, because all of these numbers are different, then they don't really have to be in separate partitions, and we haven't talked about partitions yet. So for the sake of partition questioning, let's just say they're all in the null partition, and there are no partitions. Nobody has any calling search spaces yet. So essentially, they're all considered equal in terms of partition length or partition order or anything like that. Well, let's take a look at this. This matches how many possible strings? 300. Wait a minute. You might say, wait a minute, no it doesn't, it matches 100, right? Because I've got 15XX. I've already matched 15 for that second potential placeholder of 2 or 3 or 5. I guess, Mark, I could see what you're saying if 2 and 3 and 5 were all considered. Well, as far as CUCM is considered, in terms of longest match, they are considered. This matches a total of 300-digit strings. The next one is 0 through 5. So that's 0, 1, 2, 3, 4, 5. That's 6 digits. That matches 600-digit strings, potentially. Now, in this case, it only matches, we have an exact match, but it still, overall, as a pattern, has a lower matching potential or lower matching priority because it has more potential matches, more potential strings. 15 actually contains infinite number of strings. However, for the purposes of closest match routing, in this case, it only matches 100 because it didn't have a, now, if this had one left bracket, 0-1 right bracket, and then a bang or an exclamation, then it would match 200 potential strings. But for the purposes of this, infinite is just possible dial digits. This actually, if you do the traces, if you take a look in CUCM, this is actually the best match, given that all these would be in the same partition. Okay, for the purposes of closest match routing, it only matches 15 explicitly, and then in our case, we only did 2 more digits, which could equal 99 plus 0, so 100, and then the timeout. Okay, so take a very close look at patterns in terms of what might potentially match, and I'm saying this not just for what you might configure and have to go troubleshoot if something isn't working properly, or you have to trace it and wonder why something might be matching, but also in terms of possibly inherent troubleshooting. Maybe something that, if you're taking the CCI voice lab, that the proctor's already set up for you, which they have definitely said just last week at Networkers when I was there that troubleshooting definitely comprises a good portion of the lab, 25 to 30% of the lab. It might be inherent troubleshooting, or it might even be something that they just want you to copy down some traces or some debugs onto Notepad and explain with a paragraph or two what's going on in that, and then leave that Notepad, save it on your candidate desktop or something. But troubleshooting is certainly a part of the lab. We need to understand things like this. Okay, so let's take a look at calling search spaces and partitions. I know some of these are basic concepts to some of you. However, I've also had a number of students throughout the years of teaching that just thought they understood calling search spaces and partitions, but didn't 100%, didn't fully understand them. So I just want to draw an analogy here very quickly and make sure everyone's completely up to speed on it. So we've got a DN of 1001, a directory number. This DN falls inside of Yellow Pages, or a directory. Okay? Our analogy is going to be that Yellow Pages, or a directory, is a partition. Then partitions, or directories, partitions fall within calling search spaces, or the analogy, the directories, the Yellow Pages, or whatever directory types you have wherever you're at, go in filing cabinets. And then the filing cabinets get assigned to either phones or gateways or whatever needs to make the call. Okay, so the calling order is actually opposite. So the configuration order was, of course, we had to set up partitions and calling search spaces. We placed the DNs in the partitions. We placed the numbers in the directories. We placed the partitions in the calling search spaces. Okay, so we placed the directories in the filing cabinets. And then we assign the calling search spaces to phones or gateways or what have you. That is, we assign the filing cabinets to the devices that need to place the call. They actually have to look up in their filing cabinets to see, do I even have a directory to know what that number is? This is how we build class of service, also called class of restriction. So the calling order is the opposite way. It starts at the phone, and it goes up, or the gateway, and it goes up through the filing cabinet, looks in the directories, and then tries to find an actual pattern or directory number. Remember, we said CUCM considers DNs or patterns as the same thing. Okay, so let's take a look at an example. Eloise at extension 2001, she goes through all of the directories or partitions that she has in her filing cabinet, or calling search spaces, to try to call Jack at extension 1001. Eloise cabinets of directories, she has the INE Yellow Pages and the Island Yellow Pages. However, Jack is in the lost Yellow Pages. So, a comparison's done, and she can't place the call because she does not have the proper directory to see his number. So she would meet with reorder tone. However, if Eloise does have Jack's directory inside of her cabinet, or does have his partition inside of her calling search space, then the call will go through. Okay, any question on calling search space basics before I move on, and the analogy? I want to make sure everyone really understands this calling search space bit, because calling search spaces are used just a ton in CUCM 7, and even more so in 8, and they're only going to, because they're such a great construct, they're only going to proliferate the usage more and more and more as CUCM versions go on and the system becomes more robust, more granular. We're going to be using calling search spaces and partitions for everything. In fact, I think they should stop calling them calling search spaces and rather change the name to search spaces like Unity Connection has, because it really doesn't even come close that we're only using them for calling anymore. We're using them for so much more. We're using them for SIP subscribe with presence. We're using them for calling and call-led party transformations that we'll talk about today. So search spaces in general and partitions are going to be used a lot. It's important that you understand just what's seemingly a very basic concept. Okay, so no questions. Let's go on. So if a device places a call to 1001, we see that even though partition 2 is ordered lower than partition 1, most specific patterns are always chosen irrespective of partition order. Okay? It does not matter the order that the partitions are in as long as there is a longest match. The longest match will always be chosen regardless of what partition it's in. I should say is what order the partitions are in. You have to, as we just talked about, have the partition or the directory in your calling search space or in your filing cabinet, but it doesn't matter the order. Okay, so 2001 is dialed. Now we actually have a tie. So partition order is used, but only as a tiebreaker in the case of equal matches. So here we have 2001 down here in partition 2 and 2001. In the last slide, just go back, we did have 1XXX, which would match 1001, but 10XX is a little bit longer. There's only 100 potential matches here. Here there are 1,000 potential matches. Okay, so 2001 is equally as specific here and here. Now, when there is an equal match, that's when partition order comes into play. This is going to be an extremely important concept when we talk in just a moment about something called the line device approach. Okay, so quick quiz before we move on. Which one of these 4 is necessary for Jack to be able to call Eloise? Does DN 1001 and DN 2001, do they have to be in the same partition? Will that allow them to call? If Jack's phone and Eloise's phone have the same calling search space, will that allow the call? What about both of those, all of the above? Will that allow the call, or is it none of the above? It is D, none of the above. Just because 2 DNs are in the same partition means nothing. Means absolutely nothing. If 2 phones have the same calling search space, it means absolutely nothing. If all of that's true, means absolutely nothing. Jack's calling search space, okay, so the calling search space on either his phone device or on the individual line that he's calling from, or combination, has to contain, so that is his filing cabinet must contain the directory or partition that Eloise's DN is found in. And for Eloise to call back, she also has to have the same thing. It's very possible for Jack and Eloise to have their DNs in the exact same partition, but for Jack to be able to call Eloise only and Eloise not be able to call Jack. If that were the case, Jack's calling search space or filing cabinet would contain Eloise's DN partition. However, Eloise's calling search space or filing cabinet would not contain the directory or partition that Jack's DN happens to be inside of. So I want to go back one more time to this slide, just so everyone's fully clear on this one bit. DNs fall within partitions only. DNs have nothing to do with calling search spaces. Okay? They are not inside of calling search spaces. Likewise, you do not assign a partition to a phone or a gateway. You only assign a partition to a DN. DNs go inside of partitions. That's it. Okay, now you might say, well, wait a minute, on a phone, I can put a partition. Well, no, on a line, not on the phone device, but on the line, you can put a partition, and that is the DN's partition. So the DN that you're configuring for that line, the DN is inside of a partition. Now you might say, but Mark, I can put a calling search space on the device page for a phone. I can also put it on the line page. Okay, that's true, but you are not putting a calling search space. You're not putting the line, the DN, inside of a calling search space. You are putting the DN inside of a partition. Even if you leave it the none or null partition, that's still a partition, and we'll talk about that in a moment. You're putting the DN in a partition, and you're giving it access to a calling search space to dial out of. Calling search spaces are what are considered from the calling device. So the person who goes off hook to make the call, the calling party, that party's calling search space is the only thing that's considered. Okay? The calling party's partition, or DN's partition, has absolutely nothing to do with the consideration of the call. It's just the calling party's calling search space. And again, that calling search space could be on the line or could be on the device of a phone, or, as we'll talk about in a little bit, could be on both, and we'll get to that in a moment. But the calling party only is concerned about their calling search space or filing cabinet with which to look in to find directories or partitions, with which to look in to find numbers, patterns, DNs. Okay? So once again, I know I sound like I'm, beating it into your heads, but DNs or patterns fall within partitions. Even the none partition is a specific partition. Those fall within calling search spaces, and calling parties, inbound calls. So if I pick up a phone and I pick up the handset, I am making an inbound call into CUCM. I'm using my calling search space to find on that inbound call directories and outbound DNs. If a call's coming in from a gateway, okay, in from the PSTN, in from a gateway, it uses its inbound call routing calling search space to look for directories or partitions with DNs. Okay. So I didn't hear too many questions in there, so I'll assume that everyone understands that's live. And for those of you, if you were watching this recorded and you still don't have 100% clarity on that, I would recommend you hit pause and rewind and go back to understand that DNs in the same partition mean nothing, phones in the same CSS mean nothing. The only thing that matters is that Jack's phone has to have a filing cabinet CSS that can see Eloise partition and then DN. And if Eloise wants to make the call back, her device or line has to have a calling search space as it calls in through CUCM to find the directory or partition that Jack's DN is inside of. So looking at the external call routing configuration order, and also where we can perform digit manipulations for external PSTN, or, I suppose if we're going to, whether it's a ITSP, whether it's a gatekeeper trunk, SIP trunk over to another cluster we have, T1 into a PBX, E1 into a PRI, E1 PRI into the PSTN, whatever it is we're doing, we're calling external to the cluster. It's not a DN that's on the cluster, registered to the cluster itself. That's what we're looking at now. how to configure it, and then where we can perform digit manipulation in a traditional sense. As I mentioned, once we understand everything thoroughly today in this module, then tomorrow we'll be getting into globalization and adding additional layers of complexity. So we first need to make sure that we're 100, maybe 1,000% solid on the fundamentals. Okay, so to begin with, we've got route patterns. In a traditional sense, these match dialed numbers for external calls, and they point to a route list, or they can point directly to a gateway. But if they do point directly to a gateway, that gateway can no longer be considered for usage in a route group. But in large-scale routing, the route patterns point to a route list. Route list points to prioritized route groups. Okay, so here we see we've got the first choice from this route list is route group 1. The second choice is route group 2. Easy enough. Route groups point to the actual devices, whether that's a gatekeeper-controlled trunk, a SIP trunk, a non-gatekeeper-controlled trunk, or ICT, H323 gateway, MGCP gateway, whatever. They also contain distribution algorithms. The reason for the distribution algorithms, such as circular or top-down or something like that, is that we have the ability, although we typically don't use it in the CUCM, in the CCI Voice Lab. I wouldn't say we don't use it. I would just say that the majority of our setup doesn't use it, but occasionally we probably will be using it. Route groups certainly have the ability to have multiple types, multiple gateways, multiple trunks, could have multiple different types. We could have a PSTN, PRI, H323 gateway. We could also have a gatekeeper. Now, it's typically a very bad idea to mix types of gateways or trunks within a route group. Typically, and I would conservatively say that most of the time, if not all of the time, we're going to want to put trunks of the same type or gateways of the same type into our route groups. And preferably, they would be at the same location, geographic location, and preferably they'd be with the same carrier, have the same routing characteristics, the same toll charge characteristics. We don't have to do that. You certainly don't have to follow that model. But it definitely makes for design and troubleshooting later quite a lot easier if we keep like types inside of a route group. One good example might be if we had, let's say, 3 CUCM, let's just start with 2 CUCM clusters, and there are 3 subscriber call manager servers in each cluster. In one of my route groups, I might want to put, now I could just configure an ICT trunk that has all 3 subscribers listed. Okay, if you're familiar with ICT trunks, I can put 3 different IP addresses of the 3 different subscribers of cluster B if I'm in cluster A. However, it will always contact subscriber 1 in that cluster B ICT. Unless it's not available, then it'll contact subscriber 2, then subscriber 3 in cluster B. The problem with that is that it's putting all of the load of the calls, especially if I have maybe 500 calls busy hour at once, all of them on subscriber 1. A better idea is to create 3 intercluster trunks, each with only 1 IP address of subscriber 1, second intercluster trunk, same cluster but subscriber 2, and then the next intercluster trunk, same cluster B but subscriber number 3, and put them as 3 separate trunks in a single route group, and choose the distribution algorithm of circular. This will load balance the calls, especially in high busy call hour volumes. This will load balance the calls across the receiving or terminating cluster and across their subscribers. This is the reason for distribution algorithms within route groups. And then we have the devices themselves. as we mentioned, the different types of gateways, MGCP, skinny for FXS, FXO, H323 gateways, H323 ICT and SIP trunks. And at 3 of these stages, we have the potential to manipulate digits. Okay, so a call gets to the route pattern because it matched the dialed number for the external call. First of all, we have to configure everything in the opposite direction that the call routes. The call routes from the route pattern to the route list, first or second choice, and then down to the trunks or the gateways. We configure that in the opposite order, of course. We have the ability to perform digit manipulation at the route pattern. We also have the possibility, optionally, of performing digit manipulation at the route list level. Okay, and actually this should be noted that it is route list details, so it is the route group within the route list. Route list details is where we can perform digit manipulation. So we can perform separate digit manipulation for each route group within each route list. So if it takes this path, then it's going to get 1 digit manipulation. If it takes this path, then it's going to get a different digit manipulation because we're sending it to a different place, the PSTN versus the gatekeeper-controlled WAN. Also note that route groups can be used multiple times in other route lists, but each route group route list combination with digit manipulation is its own pairing. Okay, it's its own unique combination, and route group within route list, so we called it route list details, digit manipulation that occurs within the route list detail for this combo has absolutely no bearing on this route group when it's used in a different route list. Okay, make sure you're clear on that. And then we also, new in 7.0, have the ability to perform digit manipulation at the device level. Okay, not actually in the iOS. Of course, we can do that as long as it's not MGCP, but within the device page before it leaves for the actual device. Okay, so if it's a trunk, before it goes out to the gatekeeper or goes out to the terminating SIP iOS device, if it's H323, before it leaves and goes out there. If it's MGCP, it's the last place that we can do it. But this is within the device page within CUCM, we have the ability to perform digit manipulation. Okay? Now, the reason I wrote optional here for route pattern and route list digit manipulation and preferred at the device level, first of all, before CUCM 7.0, there was no option to do digit manipulation at the device level. By the way, this is something called calling party transformation, calling search space, or call lead party transformation, calling search space. It's a mouthful. You're going to see me write it in an abbreviated form, and we'll show what that abbreviated form is so we don't have to type it out in extreme verbosity every single time. But in terms of saying it, there really is no good abbreviation. So you're going to hear me say it a lot. Calling party transformation, calling search space, and call lead party transformation, calling search space. Now, we're used to transformations. That sounds like a new term. In fact, calling and call lead party transformation, the very first time I saw 7.0 in beta, I thought, oh, they just renamed translation. Nope, they didn't rename translation. Translation patterns are still translation patterns. However, if you've ever taken a look at a translation pattern and you notice what's on the page for a translation pattern is transformations, or are, I should more properly state, are transformations. And there are 2 types of transformations on a translation page. There are calling party transformations and call lead party transformations. So when we see calling and call lead party transformations here at the device, gateway or trunk page in CUCM, this is nothing new. It's just that we're not doing the actual transformation there on the page. Also, when we're at the route pattern, We see performs digit manipulation. Digit manipulation is kind of a term we've come up with. Okay? It doesn't really appear in CUCM. Transformations is the term that appears in CUCM, and it's broken out in route patterns by calling and called. They're in separate subcategories there, and they are independent of one another. Okay, so we're going to look here in just a moment about, of all three of these possible digit manipulations, what is a trump to what? Okay, what you should know is that there is no anding with digit manipulations. There's no compounding. So if I perform digit manipulation here at the route pattern level, and other than a few bugs in 7.0.0 or 7.0.1 even, that 7.1 cleared up, but other than a few bugs, if I perform digit manipulation here at the route pattern, then I also perform it at the route list details, and then I also perform it at the gateway or trunk via CSS, this route pattern does not take effect and then goes on to add in or compound the digit manipulation of the route list details, and then goes into compound or add in the digit manipulation of the gateway's called party transformation. It doesn't do that. Okay? In fact, what happens is anything that's done at the gateway or trunks digit manipulation, we're going to talk a little bit more about this in a moment, that trumps whatever was configured at the route list details. And assuming that there was nothing at the device page, device level, then the route list details trumps what was done at the route pattern. So essentially, as I go on down the line of the actual call, any digit manipulation that was done at the route pattern level is only basically tentative. It's set to take effect if no other digit manipulation should happen to be configured on down the line. If there is digit manipulation on down the line, whatever was done previously is completely forgotten. It's like, you know what, your reservations are no longer good because somebody else more important showed up. Then as we go on down the line, route list details to the route group, we get to the device. If there is a calling or called party transformation, again, there is no actual transformation here. When we were at the route pattern, we performed whatever digit manipulation we wanted based on the calling or called, or possibly both, and they are treated independently. More on that in a minute. If I would actually perform the digit manipulation there on the route pattern page. Route list details was the same thing. I would perform the digit manipulation for called or calling there on the route list details webpage. On the gateways, I do not perform it there on the page. What I have is, and again, this is where I said the word calling search space, I think should be renamed to search space, because calling isn't really necessarily appropriate in many situations now. But what I have here at the device webpage within CUCM is a calling and or called party transformation CSS, calling search space. So what this does is builds on everything that I just tried to hammer into your head, and I had no questions, well, not too many, so hopefully everyone is up to speed on that. This looks within the partitions to see, is there a match? Is there a match on what? Is there a match on either calling or called, or both? And remember I said these are treated independently, right? So if calling and called, so if I configure calling party transformation here at the route pattern level, but I do not configure called party transformation, and then I do nothing at route list details, and then on the device web page, the gateway, let's say, out to the PRI, I have a called party transformation CSS that matches a pattern which is within a partition visible by this CSS. Okay, so my pattern has to first match the dialed digits, the original dialed digits. And I should actually maybe clarify that just a little bit more. The dialed digits as they enter the route pattern. Dialed digits as they enter the route pattern. That's what this needs to match at the gateways, or I should say at the call-led party transformation, which is within a pattern in a directory, and that directory is in a filing cabinet, and that filing cabinet is assigned here to this device at the specific drop-down under outbound calls only of call-led party transformation CSS. Okay? We'll get to that more when we actually do the tasks and the configuration, especially for local route group. I want to make sure everyone fully understands that. But again, I could do my calling party digit manipulation up here at the route pattern that is independent of call-led party transformation. Now, let's say I got down to the device level and I not only had a call-led party transformation CSS that matched a pattern, but I also had a calling party transformation CSS. However, it did not match a pattern. Does it, per this trump, does it override what was done at the route pattern calling digit manipulation? No. Just because I have a calling search space or a calling party transformation CSS, just because I have one of those doesn't mean anything. It's only if I have a CSS configured that matches a pattern inside of a partition. Then, if it's a match to the original calling number as it entered the route pattern, then and only then will it trump what happened here at the route pattern level. But just because I have a CSS configured, or if I leave the default, which points to the device pool for that, whatever device pool is configured on that gateway, and that might have a CSS, just because I have a calling or call-led party transformation CSS does not mean anything. It's only if it matches a pattern. This is a little bit to think about here at the gateways. And as I said, we're going to look at some detailed tasks and examples and hopefully fully understand it before the day's out. And the reason it's a lot to think about, more than it was before, as I mentioned, at route pattern level and at route list details, and even in translation patterns, which we're not talking about here, we've always had calling and call-led party transformations. The difference was the call had already gotten to the route pattern, and we told it exactly how we wanted it transformed there on the route pattern page. Or the call had already gotten to the translation pattern, or maybe to the route list details level, and we told it what we wanted it to do, how we wanted that calling or call-led number to transform there on the same page. The reason gateways are a lot more to think about, gateways or trunks, calling and called party transformation CSS, is because the call's gotten down to the gateway, but we don't actually transform the number right there on the page. What we do is we have a CSS, we have to create a new CSS, we have to create a new partition for the match number to go in. Then we have to create a new pattern, and we have to match the pattern as it was dialed or as it entered the route pattern area. That is the part that can become very confusing. A new CSS and a new partition for calling and a new pattern and a new totally separate CSS and partition and pattern for call-led. Now we can combine those. We won't, so that we keep very clear and very distinct, definitive boundaries as to what could potentially match anything else. And we'll talk about why in a little bit. But you don't have to. You could have the same CSS for both calling and call-led. And you could have the same CSS for calling and call-led for phones and gateways. We'll talk more about phones' possibility for doing that sort of transformation tomorrow. That gets into localization. But for today, we'll stick with at the device. And the reason for this is something we're going to be talking about very shortly, which is called local route group. So are there any questions so far just on digit manipulation, the 3 places so far for tomorrow that it can be performed, and then what trumps what, and a basic understanding of calling called party transformation CSS? Even if you have questions on it, please ask now, but we will get into a lot more explanation as well. Any questions before we move on? Okay. So now let's just take a look at class of service building. We've talked about the calling search spaces and partitions. We now take a look at, maybe we have an IP phone here, and based on the calling search space that is defined, maybe it doesn't have all three, but maybe it has internal only or local only or unrestricted. Those point to partitions. So let's take a look. Internal only points to internal, such as all IP phones. Now we could divide those up into further partitions. We could divide up by site or by type of group, sales, marketing, support, finance, things like that. But we're going to keep it simple for right now and keep all phones in one partition. And we'll keep all voicemail, all media resources like Meet Me DNs or Call Park or Call Pickup. 911 route patterns we'll actually keep as internal as well, just because everyone should be able to dial emergency. Then we've got local only. Local CSS can see both internal and the local partition. And the local partition has patterns that we can dial out to the PSTN for local numbers. And then we've got unrestricted. So here we've got three CSSs. Unrestricted has internal, local, and long distance. And maybe it would have international as well. We just don't have that one drawn. So we can create a number of class of restrictions or class of service. Those two could be somewhat synonymous. Class of restriction or class of service. You'll hear me referring to them as both, or referring to them as either one. Based on calling search spaces, or CSS, that contain one or more partitions. That's just the basics of class of service. We also have, there is also always the null or none or default partition. Okay? If I don't configure a partition, when I do configure a DN, I have actually assigned that to a specific partition. It's just the null partition. There's also, if I didn't configure a CSS or calling search space for a device, it has the very specific calling search space of the null or default or none, all synonymous with each other. None or null or default CSS. The null CSS only contains the null partition, and only can. It's non-configurable. You cannot change it. However, all other CSSs that you ever configure all have the none partition. This is the same way that when we talked about media, if you watch that module, that the null media resource group list had the null media resource group, but then every other explicitly defined media resource group list had the null media resource group as well. And by the way, in terms of order, that partition is always ordered last. So for instance, if unrestricted has internal partition ordered first, then local ordered second, then long distance ordered third, none would always be last. And it's non-configurable. We don't see it, but it is there, and it's important to remember. So if we look at a traditional class of service construct, we've got, let's say, Seattle phones. We've got Seattle restricted calling search space. This can only see the 911 partition for emergency, and then also the internal partition with all of our on-net DNs. We'll talk about on-net versus off-net calling in a little bit. Then we've got another Seattle phone which has got the unrestricted partition. It's got the 911, the regular PSTN, which contain local, long distance, and international patterns, and also the internal. Okay, so the arrows get a little bit confusing, but you can make them out. Now, other than internal, which are registered directly to those devices, so they don't need to point to anything, these route patterns all point to, in this case, a route list, which points to a route group, which points to the gateway. But you can see that by giving, let's say, the Seattle restricted calling search space only access to 911 and internal, we've effectively shut them out from dialing any, they can't dial any local, long distance, or international numbers. They can't dial to the PSTN at all except for emergency calls. Here is our traditional calling search space construct. We've also got Austin, Texas phones here. These are two of the sites we're going to be using. So with those, we also have to have new route patterns for 911 and PSTN partitions. That way, they can point to their own route list, which points directly to the Austin route group, which contains the Austin gateway or gateways. Okay, so the idea is that we have to have multiple route patterns, even though if you take a look at these route patterns here for Seattle, 911 and 9.911, just so if someone goes off hook and dials 911 or the PSTN access code 9 and the emergency code 911, both will work. And all four PSTN patterns, those are the exact same as the Austin patterns, aren't they? Now, not every locale is like that, whether you're in the US, North America, or elsewhere, but many are. So, gosh, I mean, we have to create a lot of patterns. We have to create two partitions for each city, and this is just if we only want two class of restriction or two class of service, being restricted for Austin and unrestricted for Austin, restricted for Seattle, unrestricted for Seattle. So device calling search space indicates the class of service and the path selection. Okay, so typically calling search spaces, or I should say traditionally, calling search spaces, if we use the traditional approach, which is what this is, they're there for two main reasons. One is site-specific call routing or path selection, and the other is our class of restriction or class of service. Okay? And what this means is that in order to get class of service and site-specific call routing or path selection, the number of calling search spaces we have to create equals the formula n times c, where n is the number of sites and c is the number of classes. So if we had 1,000 sites, and here we only show 2 sites and 2 class of restrictions each, but having 4 class of restrictions is fairly common, at least within the US. Okay, so we would have restricted calls, which can only call emergency and internal numbers. We'd have local calls as a class of service. We'd have long distance calling as a class of service, and we'd have international. And depending on who your manager was in your enterprise organization, that would determine most likely, or some sort of corporate policy, what type of dialing you were allowed to perform on your phone. One of those 4 class of restrictions. Some places have less, like we show here, only 2. Some places have far, far more. We're going to get into, in our lab, just to keep configuration short so that we don't spend forever duplicating our efforts once we understand the concept, we're going to use 2 class of restrictions. But let's just think conceptually here, a standard organization, now I know 1,000 sites might be a lot. I have seen clusters with 1,000 sites, but only 2. And typically you'd have clusters with about, 200 to 300 sites. But let's just say, for the sake of example and understanding the magnitude, that we have 1,000 sites and 4 class of restrictions, which is pretty common. If n times c, so number of sites is 1,000 times 4, that's 4,000 calling search spaces we have to configure, 4,000 partitions, and for every type of route pattern, we have to configure 1,000 of those types of route patterns. So 1,000 911s, one for every site, 1,000 9.911s, one for every site, 1,000 locals, 1,000 long distance partitions, 1,000 international, and 1,000 international with that hash for interdigit timeout. We've got 6,000 patterns that we have to create here. Okay, this is the traditional class of service. This is what, truthfully, today, in 90% of the deployments that I go to, either to consult with for design or help out with some troubleshooting on maybe an issue that's going on, or occasionally even design a greenfield deployment. I don't have a ton of time to do that anymore, with teaching being mostly what I spend my time doing. But whenever I consult or add on terms of consulting, 90% of what I see is the traditional class of service construct. It's a fine one as long as you're a fairly small company. But if you ever happen to or plan to merge with another company or grow at a fast rate, or even just want to cut down your administrative duties and troubleshooting possibilities, this quickly gets out of hand. Even for small sites, even if you only have 10 sites. Okay? Even if I only have 10 sites, that's still 10 times 4 class of restrictions. That's still 40 CSSs, 40 partitions. And if I've got only 6 patterns, that's still 40 times those 6 patterns, or 240 patterns I have to build. So breaking from the traditional class of service, let's take a look at something called the line device approach. Now that we understand how calling search spaces work, they only work on the ingress of a call. So as a call's, someone's gone off hook. Whenever someone goes off hook on a phone, what happens? They not only go off hook on the device itself, but they also go off hook on one particular line within that device, right? They don't go off hook on all the lines. So I might have 3 lines configured here. Each line has a separate CSS on it that could be used, and then the device has a CSS. Well, what's taken into account? Surely not line 3's CSS or line 2's CSS. Why? Because I didn't go off hook on those lines. Now, if I had, then one of those would be. But I can only go off hook on one line at a time. So I went off hook on line 1. So the CSS from that line and the CSS from the device are both possibly taken into account. Let's take a look at how this works. If the device, actually let's look at the line CSS, has partitions L1, L2, and L3 inside of that CSS on line 1. And then on the device, there's also a calling search space, but it's a different calling search space, and it contains different partitions, D1, D2, and D3. Okay, L for line, D for device. Remember, only one line I can go off hook on, so the line I went off hook and the device calling search space, anytime I go off hook, if they are both configured, are concatenated into a resulting new calling search space where the order of the partitions in that new calling search space are line first, device second. So whatever order the device partitions, device calling search space partitions were in, they remain in that order. Whatever partitions at the line level were in, they remain in that order. However, all of the partitions in the prior order they were in are stacked on top of the existing prior order of the device partitions. So now, if I had a separate CSS for the line and the device, then anytime I have any sort of direct tie between pattern matching, then I'm always going to choose the line partitions pattern matching as prioritized over top of the device partition DN matching. Okay, you might say, why would I ever want to have, if you've never looked at this approach, why would I ever want to have 2 calling search spaces, 2 different calling search spaces, one at the line and a different one at the device? That seems too complicated, and why would I want to take this into consideration? I thought you were just talking, Mark, about traditional class of restriction or class of service as a construct and possibly simplifying our troubleshooting. This doesn't seem like simplifying. Well, if you really sit back and take a look at what we're going to look at next, which can be a fairly easy to grasp concept, you'll understand why we very well might want to have line and device as 2 separate CSSs. But it all gets back to that idea that longest match wins, first of all, regardless of order of partition. So in other words, if partition L1 does not contain a pattern that matches anything that D2 matches, and neither does L2, L3, and D1. Those do not have the pattern that D2 matches. Then the pattern that I dial that matches a pattern inside partition D2, it will be chosen. longest match is still chosen regardless of order of partitions. However, if we have D1 matches the pattern I dial, let's say 911, and L1, or even let's say L3 also matches the pattern of 911, then because if they are direct tie, if they both equal the same number of potential patterns, maybe they're both 91X and 91X, or 911 and 911, they're both equal matches, then the order, the lines L3 partition will take precedence because of the ordering of the partitions within the resulting concatenated CSS. And again, the none or null CSS, the default is still always at the end. So there's actually 7 partitions here. 3 for L, 3 for device, and then the null partition.